Hello there, Cardinals. It's me, Mr. Ernst, and today I'm going to be showing you, well, actually, we're going to get our first introduction to the Pythagorean Theorem. And I just had to double check to make sure I spelled that right. It's a weird name from a weird guy, but the Pythagorean Theorem is one of the big geometric proofs of our grade level. And the first use we're going to do, you'll notice that there's a colon at the end of this because we're going to use the Pythagorean Theorem a lot. And the first skill we're going to look at is identifying a right triangle. So, to start off, a Pythagorean theorem only works with a right triangle. Okay, it does not work with obtuse. With an obtuse triangle, it would not work with a acute triangle, a little tiny acute one. It only works with right triangles. Okay, and that is a very key thing to know. So, many of you are already familiar with it, but let's talk about it now. The Pythagorean theorem states that we have a squared. Actually, I'm going to write this differently. It's a squared plus b squared is equal to c squared. But the first time we look at this, I'm going to write it out like this. Side squared plus side squared is equal to the hypotenuse. Hypotenuse squared. The hypotenuse is always going to be the longest side of the triangle, okay? For a right triangle, that is always the one that is opposite of the right angle. Hypotenuse, 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 hypotenuse. So this is going to be my hypotenuse. It's always the one opposite the right angle, and it's always the largest side. So the two smaller sides squared is equal to the hypotenuse squared, okay? So let's write this out. The very first one we have is 3, so that is our first side. So we have 3 squared plus 4 squared is equal to, and our hypotenuse is 5, so this is going to be 5 squared. Notice these numbers do have to be squared, because if I was to go back and erase these squares, this is not a true statement. 3 plus 4 does not equal 5. So you'll notice that the Pythagorean theorem, despite being on a right triangle, it's all about the squares. I almost put to the power of 5 there. There we go. 3 squared plus 4 squared is equal to 5 squared. We simplify this out now, so 3 squared is going to be 9. 4 squared is going to be 16. And 5 squared is going to be 25. And now we have our true statement. 9 plus 16 simplifies to be 25 is equal to 25. And that is the Pythagorean theorem in action. Smaller side squared plus smaller side squared is equal to the hypotenuse, or the large side, squared. Again, this is only ever going to work for right triangles. So, because it only works for right triangles, we can actually use the Pythagorean theorem as almost like a sensor. So here I have 2 different triangles, 6, 8, and 10, and 2, 3, and 4. But only one of them is a right triangle. We don't know which one it is. However, we do know the Pythagorean theorem only works with right triangles. So what we're going to do is we're going to use the Pythagorean theorem as a sensor to figure out which one of these triangles is a right triangle. So starting off with this one, we have small side, we have 6 squared plus 8 squared is equal to, this is my hypotenuse, 10 squared. Okay? I'm going to do the same thing over on this side. Again, small side is 2 squared plus 3 squared is equal to, and this is going to be 4 squared. My hypotenuse on this side is going to be 4 squared. Now we go through and simplify them, okay? 6 squared is going to be 36. 8 squared is going to be 64. And then 10 squared is going to be a nice even 100. 36 plus 64 gives me 100 is equal to 100. That is a true statement, so we know that the Pythagorean theorem did work on this triangle, which means this is a right triangle. This blue triangle is a right triangle. Now let's watch what happens on the right-hand side. 2 squared gives me 4. 3 squared gives me 9. 4 squared gives me 16. 4 plus 9 on this side over here gives me 13 is equal to 16. This is not a true statement, which means that this triangle up here is not a right triangle, because the Pythagorean theorem did not work with it. You can use the Pythagorean theorem to identify a right triangle. So this one, yes. This one, no. Okay? That's it for this video, and thank you for watching.